what we're given here is a graph of a function f from -2 to 5. And we're also told that it happens to be continuous from -6 to 5. Tells us a couple of important pieces of information. One, that the first two pieces of it are line segments, and two, that this is a quarter of a circle. And the center of that circle would be at the point 5, 3. They also tell us the coordinates of the point 3 and 3 minus √5 are on the graph. So that's part of the circle right there. So that's all the stuff that's given to us. And then they tell us that the integral from -6 to 5 of f of x is 7. And want us to find the value of the integral from -6 to -2 of f of x. Well, if I know that the integral from -6 to 5 of f of x is a certain value, but I want to know the value of the integral from -6 to -2, what integral would I have to add to that to make this equivalent?
-2 to 5.
-2 to 5. Everybody agree that the integral from -6 to 5 should be the integral from -6 to -2 plus the integral from -2 to 5. Would we all agree with that?
Yep.
Okay. Well, the one that we're looking for is the integral from -6 to -2. So that ought to be the integral from -6 to 5, which is 7, minus the integral from -2 to 5 of f of x dx. Ought to equal the one that we are looking for. Everybody good with that?
Yep.
All right, so that integral that we are looking for should be equal to 7 minus whatever the integral from -2 to 5 is. Well, the integral from -2 to 5 is just the area underneath the curve. So first off, from -2 to -1, I'm above the x-axis. And from -1 to 0, I'm below the x-axis. And this in blue here and this in blue here ought to be exactly the same, shouldn't they?
Yep.
Would you agree with that? One's positive and one's negative, though, so those should cancel out.
Yes.
Okay, so this is positive a half, this is negative a half. I can ignore that. Down here, I should have this little section, a half by 1. And this little section, which is a half by 1, those should also cancel out. Would you all agree with that?
Yes.
Okay, so then all that's left is to figure out what's left of this. So the piece, I wish I could get another color working here. Cool if this would work. Guess it's not gonna let me use another color. All right, this section here, which is just this trapezoid that I'm outlining, we should be able to find by doing base 1 plus base 2 divided by 2 times the height, which is 1. And then the chunk here that comes from the quarter circle needs to be the entire area of that square, which is 9, minus the area of the quarter circle, which is 1/4 pi times the radius squared. So this chunk underneath here ought to be 9 minus 9 pi over 4. So this plus 9 minus 9 pi over 4. And then we'll just go in and evaluate everything. So 1 plus 3 is 4 over 2 is 2. So really we've got 7 minus 2 plus 9. So that'd be 11 minus 9 pi over 4. And that should give us a positive 9 pi over 4 minus 4. Everybody good with that? Any questions on part A?
So is an integral, isn't it like the area between the line and like the x-axis? Isn't that like the technical definition? So if it's below, it
It's
would be
the
negative.
integral, no, the integral does not define the area. The integral is the area if you are above the x-axis. If you're below the x-axis, it is the opposite of the area.
Okay. So that would be a negative value if it were to be below, because I just made that a positive value, which made it an issue with the calculation. So if it was below, it would
This
turn
is a
out to be
positive value.
negative. No, but like when you were canceling them out at the beginning and you were like, this triangle is the same as this
Oh,
triangle,
you
so
made
they
this
cancel out.
positive also?
Yes,
Okay.
yes.
Yeah,
So
that's
if it's
problem.
okay,
The
so it should be
integral has
negative.
the integral has a sign to it. The area itself does not, but the integral itself represents a positive number if you're above and a negative number if you're below.
Okay. Okay. Thanks.
Okay. Any other questions there on part A? All right, part B, we're going to evaluate the integral from 3 to 5 of 2f prime of x plus 4. Well, we could separate this out if we wanted to into 2 times the integral from 3 to 5 of f prime of x dx plus the integral of 4 dx from 3 to 5, which should make this pretty easy. What's the integral of f prime?
F of x.
So we'll evaluate it at 5 and 3 and find the difference. And then this just becomes 4x from 3 to 5. Good or no?
Good.
All right, f of 5 is 0. F of 3, oh no, that's a really annoying value to find. Oh, no, they gave it to us. And then plus 20 minus 12. So we end up with a -6 plus 8, which should be a 2. And then negative 2, or negative root 5 times the 2 is a plus 2 root 5. Everybody good there with that one?
What was the point breakdown for A and B?
Sorry, so for A, let's see, if you set up this integral at all like this, that's 1 point. Finding this value of 11 minus 9 pi over 4. No, not finding 11 minus 9 pi over 4. Finding 11 minus 9 pi over 4. That was a second point, and then the final answer was a third point. And then here, recognizing that the integral of f prime was f from 5 to 3 was a point, and the final answer was a point. So 5 points total from A and B. Any other questions there on A or B? Okay. Part C says we have some new function g. G is given by, it's the integral from -2 to x of f of t dt. So we want to find the minimum of g, the absolute minimum. No, sorry, maximum. I can read the absolute maximum of g on the interval from -2 to 5. Note that this is a closed interval, so it's guaranteed to have an absolute max and an absolute min. We only need to find the max. And we also need to check the endpoints as well as any critical values of g. So to find a critical value of g, we need to take its derivative. And what is the derivative of g? Based on this, the derivative of g should just be
F of t.
Should just be f of x. And so we are looking for when is f of x equal to 0? And when is f of x undefined? And if you look at the graph, first of all, it's never undefined, right? F of x is defined for that entire interval. But it does equal 0 a couple of times on there, right? It equals 0 at -1 and at 1/2. Also at 5, but that's an endpoint, so we would check that anyway. So -1, positive 1/2. This is never. And we're going to check all of our values, starting with -2, -1, 1/2, and 5. So both of my endpoints and both of my critical values, and find the value of g of x at each of those. And that will tell us which one is the absolute max. So we know that g is the integral from -2 to x of f of t dt. So what's the integral from -2 to -2 of f of t? That ought to be
0.
0. What about from -2 to -1? Well, from -2 to -1, I should get an area of 1/2 base times height, which is 1/2 of 1 times 1, or 1/2. So immediately I know that my max is not at -2. So it could be at -1. What about at 1/2? The integral from -2 to positive 1/2. Well, this -2 to 0 cancels out, and then I just have the 0 to 1/2, which is -1/4. I find the area of that little tiny triangle. So clearly that is not the absolute max since it's less than half. Then we'll look at 5, the integral from -2 to 5. And what was that integral from -2 to 5? It was 11 minus 9 pi over 4 from part A. And is that more than half? And the answer is most definitely yes, because even if pi was 4, we'd have 11 minus 9 here, which would be 2, right? And that's more than half, and pi is certainly less than 4, so this thing is way more than 2. So this is our absolute max. It is 11 minus 9 pi over 4, and it occurs at the endpoint of x equals 5. Any questions there on part C? Breakdown was 3 points, 1 for recognizing that G prime is F, 1 for identifying this as a possible candidate, and 1 for getting the correct value at 5. So making sure that you check the endpoints.
Can you go back to the graph real quick?
Yeah, and it's very common in these types of questions for them to ask about maxes or mins on either closed or open intervals, and just make sure that if it is a closed interval that you also have to check the endpoints.
Okay, thanks.
Yep. Any other questions on A, B, or C before we move on to part D? All right, part D, we're looking for the limit as x approaches 1, right? 10 to the x minus 3f prime of x over f of x minus inverse tangent x. All right. And so a lot of the time, and I would say a good majority of the time, when they just give you some random limit, usually it ends up being L'Hopital's rule. And so they're probably just thinking people will immediately go to L'Hopital's rule with this and then get an incorrect answer. But doesn't really require L'Hopital's rule. If you plug in 1, you get 10 minus 3 times f prime of 1. So f prime of 1 is the slope of f at 1. Well, the slope of f at 1 is 2, right? Up 2 over 1, up 2 over 1 for this linear piece. So times 2, and then over f of 1, which we should be able to find. F of 1 is just 1. We can see that from the graph. And the inverse tangent of 1 is pi over 4. So we end up with 4 over 1 minus pi over 4. And that's your final answer. And part D was just worth 1 point. said this before, 1 point here for this and 1 point for deciding that was the final answer. Any questions on any of that? Feel okay about that or no? All right. This is the next one we're going to take a look at.
Are these by any chance up in the drive or no?
They are there in the assignments folder.
All right, sweet.
Yeah. So I'm going to give you guys 15 minutes. This is, again, a non-calculator one. So 15 minutes to work through this one, then we'll talk about it, and hopefully we'll have time for one more after this. So ready, go. So for part A, well, first off, if we look at this, this is the graph of G, and G is the derivative of F, and tells us that G is piecewise linear for all these pieces up until we get to 3, where then it becomes this parabola from 3 to 6. So first thing it says, if f of 1 equals 3, what is the value of f of negative 5? Well, we got to think about how to find values of f. Values of f should, in this case, come from the integral of g, right? Because the integral of g should be f if the derivative of f is g. Right. And so in order to figure out any of these values with negative 5s and 1s, we just sort of need to set up an integral that says that the integral, let's see, I'll write it up here. That the integral from 1 to negative 5 of g of x ought to equal f of negative 5 minus f of 1. You guys all agree with that?
Wait, where'd you? What? Wait, I'm not getting it. Can you just go through it one more time and explain what's going on the right side of the equation?
Well, the integral of g is f, right? If f is the derivative of g, then the integral of g should be f. So if I integrate g, I should get f, and I need to evaluate it at my upper limit, and I need to evaluate it at my lower limit.
Oh, I see. Okay.
And so in order to find the value of f of negative 5, we'll just plug in the value of f of 1 here. So we'll say that this integral from 1 to negative 5 of g of x dx equals what we're looking for, minus 3. So we'll add the 3 over. 3 plus the integral from 1 to negative 5 of g of x dx is equal to what we're looking for. And to find an integral from 1 to negative 5, that's going backwards. That's kind of annoying. So we could flip the limits and say 3 minus the integral from negative 5 to 1 of g of x dx. And so then we'd want to figure out what that is. And so that should be 3 minus, and what's the integral from negative 5 to 1 of g? Well, this piece is negative 9. This second piece here is negative 3/2, being below the x-axis. This piece here is 0 because it's just horizontal there on the x-axis. And from 0 to 1, it should be this little triangle, which should be a positive 1/2 of 1 times 2, or just a positive 1. And so that should be the value of f of negative 5. 3 minus negative 9, so 3 plus 9 is 12, plus another 3/2, so it's minus a negative 3/2. So 12 is 24/2, plus the 3/2 is 27/2, minus the 1 is 25/2. Any questions there on part A?
How many points was that worth?
That was worth 2 points. So 1 point. 1 point for using this integral in some way, and 1 point for the final answer.
And was the way you just did it the only way to do it?
Pretty
much.
Yeah. Yep.
Okay.
There would not have been, I mean, you could have written this as like -5 to 1 to begin with or something. And then you'd have f of 1 minus f of -5. But same concept.
Can you explain why you chose to make the lower limit 1?
I'm sorry, say that again. Explain why what?
Can you explain why you chose to make the limits 1 to -5 instead of the other way around?
That's how I happened to write it. It could have done it the other way and that would have been fine too.
Okay.
Yeah, it really doesn't matter either way. All right, part B, let's evaluate the integral from 1 to 6 of g of x. So that's just the area under the curve from 1 to 6. So that should be pretty straightforward. The first part from 1 to 3 is 4. So for part B, we're going to write this. We're going to separate this as an integral from 1 to 3 of g of x plus an integral from 3 to 6 of g of x. Just because we have a linear piece and then this parabolic piece. So we got to do them separately. So the first part is 4. And the second part should be the integral of 2 times x minus 4 squared, which ought to be 2/3 of x minus 4 cubed, evaluated from 3 to 6. And let's see here. That'll be 4 plus 2/3 of 8 plus 1. You plug in the 6 and the 3. So that would be 19, and 9 times 2 is 18/3. 6 plus the 4 should be 10 for part B. And even though part A seems a lot more difficult, and it was only worth 2 points, part B, which should have been much easier, was worth 3 points. 1 point if you recognize it needed to be split into 2 pieces. 1 point for correctly taking that antiderivative, and 1 point for getting 10 for your final answer. Good or no? All right. So for part C says that for -5 to 6, we want to know, are there any places where f is increasing and f is concave up? So if f is increasing, that means that f prime had better be positive. And if f is concave up, it had better mean that f double prime is positive. Well, if g is the derivative of f, this would indicate that g would need to be positive and that g prime would need to be positive. So we are looking for anywhere where g is positive between -5 and 6 and where the slopes of g are also positive. So g is positive after 0, right? Everywhere to the left of 0, g is negative, or it is 0. So g is going to have to be positive. X is going to have to be positive. So it's got to be 0 to 6 somewhere. And then if g prime is positive, that's when is the slope of g positive? Well, the slope here is positive. Not positive here, not positive here, but the slope is positive again here. So our slope is positive and our function is positive, both from 0 to 1 and from 4 to 6. And that was worth 2 points. 1 was for the actual intervals and 1 was for explanation of why that's true.
Would you have to have stated that the whole proof you did on the left there, or could have you given like a lengthy explanation with words instead of
Yeah, that would have been fine.
Okay.
You can always give a lengthy explanation in words if it asks you to explain. Just seems easier to write this, but. Any other questions there? All right, part D says find the x-coordinate of each point of inflection. I guess we didn't need this page for D, or for C. So for part D, we're looking for the x-coordinate of the points of inflection of F. So points of inflection for F should occur when F double prime is 0 or when F double prime is potentially undefined. So F double prime equals 0 or F double prime undefined. And we also have to have a change in sign at that value. So let's look at where is F double prime 0 and when is F double prime undefined? Well, that'd be when G prime is 0 or when G prime is undefined. So anytime that the derivative of G doesn't exist. So that'd be at -2 where there's a corner. That'd be at -1 where there's a corner. That'd be at 0 where there's a corner. That'd be at 1 where there's a corner. That'd be at 3 where there's a corner. And that'd be at 4 where there's this local minimum, right? Where that's where F prime would be, or G prime would be equal to 0. So all of these different places, at -2, -1, 0, 1, 3, and 4. But only one of them actually gives us a point of inflection. I wish I could sort of erase all that so we could see that better. At -2, the slope of G goes from 0 to positive. That's not a sign change, right? It doesn't go from negative to positive. It goes from 0 to positive. Then it goes from positive to 0. Again, not going from positive to negative, not a point of inflection. Goes from 0 to positive. Again, not going from negative to positive or positive to negative, not a point of inflection. From positive to 0, same thing. From 0 to negative, again, same thing. Now it goes from negative to positive at 4. So we have a sign change for G prime. G prime or F double prime changes signs at x equals 4 only. So that at x equals 4 is the location of our point of inflection. Good or no?
Wait, so what made all those other points like not points of inflection? Like what was the criteria that they had to meet that they did not?
That G prime has to change signs. Has to go from positive to negative or from negative to positive. G prime is the slope of this function, slope of G. So for example, at -2, we went from a slope of 0 to a positive slope. That is not going from negative to positive or from positive to negative. Here it's positive to 0. Again, same thing. Here it's 0 to positive, positive to 0, 0 to negative, and then finally negative to positive slopes. So only at the place where it changes from negative to positive or from positive to negative is it.
Okay, thanks.
Yep. Any other questions on that one?
What was the point values for D?
For D, just 2 points for the answer with a reason. Or really 1 point for the answer, 1 point for the reason. Right, so answer is x equals 4. Reason is G prime or F double prime changes signs there. All right. Here is another one, and you have time to do this for a few minutes. I'm going to give you guys about 10 minutes to look at this one and try and finish it up on your own tonight while you're also working on all that multiple choice. So this will be the last one that we do today.